A wonderful good morning to you all. And it's a windy day today, I see. Well, no matter. It's a beautiful day anyway. So, today we are going to talk about robustness. Robustness in code, more accurately. So, the reason that I'm making this little video of mine is because the other day I had a invigorating discussion with a few colleagues of mine. We were discussing a concept, or rather a practice, that I personally have started to frown upon more and more. And for those of you who don't know it, I'm fairly new at my new job. I'm basically the new guy. I do have quite a bit of programming experience since before. However, it's always the case when you're at the new job that you kind of, especially in programming, you kind of want to feel the waters a little bit. You don't just want to go crazy and do everything the way that you usually do it, because it's a team effort. Remember that, everybody. And so you usually make a few attempts here and there in a story that you're working on, and then you ship the code, or rather you push the code to your repository, and there's a code review, and then people get to say what they think about what you wrote. So we had a discussion about a couple of functions that I wrote, where I basically have a input of an object input. This is in JavaScript, and I am a big fan of using the get function from the Lodash library. And the get function, in essence, allows you to in a string express dot indexing into an object, or a nested object structure, or an array, or anything of that nature, with certain with the properties that you're looking for. And if it doesn't find the path to the value that you're looking for, you can specify a default return value. Now, what's so useful about this? Well, the use is that now you can safely index into an unknown data structure without ever causing an undefined error. And to me, that's very powerful, because the way that I like to write code is that if I have a function, I want that function to never ever throw an error unless that is my intention. Now, the reason for that is that I believe in the idea that it is better for the program to keep on executing rather than throw an error. Because if you throw an error, all of a sudden you're in a situation where you might actually break the entire application for a user. In Reactland, which is where we are working, this basically means that the page won't render, or the component won't render, if you throw an error. And my argument is that I prefer there to be a subtle bug or whatever, rather than throwing an error and ruining the entire page if there's an error in computation, because I don't actually know, for the most part, what the user is doing on my page. Maybe they don't care about the computation that my specific function is now making. Maybe they're not even noticing that there's a problem. And if they notice that there is a problem, we'll solve it when they notice it, because let's be honest, every single application has bugs. However, you don't mention all of them, or you don't notice all of them, because some of them you don't actually see, or some of them you're never going to encounter, because there's a very specific combination of things that has to happen for that bug to take manifestation. And even then you might not noticed. So my colleagues, on the other hand, said that they preferred that I made assumptions, because in essence the object in question was actually specified higher up in the file, or rather in the file structure. And they said that, in this context, I know that value that you are so carefully trying to index into, well, it's always going to be there. So why do you have to do the extra checks? And I said, well, because I believe that it's a very bad practice to write code that assumes things about its environment. I actually argue that that's the reason why we're all moving towards modularity. And this is a tip for all you React people out there. If you are creating a React component that assumes this is classic, you pass a React component an array, and you have code in your code base, or rather in that component, that says array dot for each or map or whatever, and then it dumps out maybe a list of elements into the DOM. Without guarding that, you have a very poorly, in my opinion, very poorly written component, because that means that if that thing isn't there in the exact way it's supposed to be for any reason, your code will break. And to me, that is bad. That is really bad, because now your component, instead of just rendering, even though it's not rendering in exactly the way it's supposed to be, it's now breaking itself and all of its children, just because you didn't do your homework or did a bit of checking. Now, this is not a problem in typed languages, but we're in JavaScript land, so we have to do, in my opinion, we have to do these things. So what I was saying to them was that, you know, like, because they are very sold on the React mentality, and I argued that this is exactly how it should work. I said, I don't want my code to know, or rather depend on, things working out higher up in the call stack, in the call chain, because my function should be well crafted as a standalone function. I don't, like I said, I don't think it's a good idea to sit there and kind of, or rather, how do I put this? When you are working on a story, you are taking a lot of time, and this is what's happening right now. We are taking a lot of time to understand the full spectrum and the whole context of the story that we're working on. The problem is that as more and more complexity is added to your application, you might find that knowing all of the stuff that's going on in the context, or knowing all of the specifics, gets really difficult for some developers. So to me, I kind of used the example. I said, well, here you are working on everything in this entire, you are implementing all of this, and you're writing code that assumes that the person who's reading your code knows all of these different specifications that you now have in your head. And in 6 months, there's an error or a bug or something, a stack trace, even better. If there's a stack trace and something broke in this flow, because some things change gradually over time. And that's what I'm telling you, that's what I'm trying to get them to understand. These things do change. You are only feeling secure about that object that you were so sure it's going to be there. You're only sure about that right now. And you're basically writing worse or less robust code because you're lazy. Because you think that it's going to always be there. And that's okay. I'm not saying that you shouldn't, but that, in my opinion, is worse than just making sure that your function handles the error cases. I mean, we do that for all other code, so why not put it at the function level? And basically, the reply I got was, in my opinion, a little bit of a nonsense reply, where they said that, oh, because I think that my code gets less cluttered and it's easier to read if there's not a guard check or something. I said, so what you're saying to me, because it's literally just one line of code more to do this extra check. You said, so that extra line there, that's what what the issue is. Like, that's where you feel that all that cluttered code and hard to understand, like that makes things less understandable in your opinion. And kind of it boiled down to finally we kind of arrived at that it was an emotional preference for my colleague, and you know, I'm okay with that. It's okay to be emotional sometimes. I don't personally think it's a good practice to allow your emotions dictate how you write your code, but so that everybody does it. I do too, don't get me wrong. So that's kind of what I wanted to make this video about. I was saying, and this is something I see a lot in JavaScript. So what usually happens is that you start at an arbitrary point in the execution of the program, and then you start looking, you test to make sure that you understand, okay, this is my current case for a feature that I'm working on, and everything's working right now in this way. And because it's working in this way, I can now not do any checks or error handling or anything like that in any abstractions that I add or functions or whatever, because I know that all these things are here, and they're, you know, I assume that they're always going to be there. So now I write my code actually worse than I could. And I do it solely because well, we all have our own reason, but I'd like to think that the reason why we do that is because of laziness, or rather because we are not thinking long term about the stuff that we're making. We're simply trying to, well, we're focused on solving our own problem right here, right now. And I honestly think that the kind of the crescendo, or like the note I want to end on is that if you're a React person, which is in this, or rather this doesn't have to be React now, but the entire front-end world, everything in JavaScript is moving towards modularity. And I like to think that the mentality that you should have, it's the one that I try to have, is that I don't want my system, or rather I want my system to be well crafted, because every single little piece that makes up the entirety of the system is well thought out and well crafted. It is isolated, it's modular. Each component in of itself, every function is a well crafted function that then make up a very robust and strong system. I don't want to have a good system that is so interconnected and dependent on overhead knowledge and, you know, the current manifestation of the system. So basically how it's working today, and that's like having a system that is built in that way is very brittle. It's not easy to change. It's not easy to plug, to update and so forth. So that's my little rant about having what I call robust code versus easy code.